Get ready. This one's going to be a doozy. Hi again, everybody, and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtual Wait, aka Mike Smith, and today we're going to talk about the await statement. Now, this video is a lot more involved than our normal videos, so just hang in there, follow along, and I guarantee you're going to be learning something really wonderful. Now, what does await do? Await simplifies asynchronous operations within JavaScript. So what I'm going to show you today is, first of all, a callback sequence that kind of shows you the old ancient way of being able to do asynchronous communication in JavaScript. Then I'm going to show you what promises are all about, which was the solution to doing what we call callback hell, and I'll explain that here shortly. And then we're going to show you the await, which made promises even easier. And finally, I'm going to show you a real-world example of how await makes your life a lot easier when doing asynchronous communications. Ready to go? Strap yourself in. Let's get started. Now, to show you how await works, first we're going to be needing to create asynchronous operations within JavaScript, and the easiest way to do that is with the setTimeout method. Now, the setTimeout takes two arguments. The first argument is a callback function. The second argument is the amount of time to wait. And what will happen here is that setTimeout will say, okay, I'm going to wait a certain number of milliseconds, and then I'm going to execute this callback function. So each one of the four different setTimeouts I have in this list here will execute after 500 milliseconds has occurred. But what makes this asynchronous is that once setTimeout has recorded that callback function, it will then continue on to the next command within JavaScript. Remember, JavaScript is an interpretive language. It basically starts at line number 1 here and continues operation. Line number 5 will not run until line number 1 finishes its run. Well, here, when we do the first setTimeout function, it will register itself, it will do what its thing, but then instead of waiting 500 milliseconds, executing the function, and then going to line 19 in this case, it will just then immediately go to line 19. So what I would expect to happen is that before I get to my final console.log params here, which will happen after 2 seconds, this will print out first. And this gives me the asynchronous ability for the setTimeout. Now let's see how everything works. So let's first take a look at what I want the final result to look like. So let's flip over into Node and type in Node callback. And again, obviously, as you can see here, the assigned all timeouts came out first, which kind of proves that the asynchronous works because that comes out after the final console.log. But I have 4 operations that I'm going to be doing here. The first operation is to get the full count, and that is the full number of elements within the array, and this happens to be my array here. The second operation is going to count the number of elements that start with the letter C. The third operation is going to count the number of elements that has 6 or more letters in it, and the fourth one just actually prints it out here. But the key here is that after 500 milliseconds, I'm going to call the full count first. Then after 500 milliseconds, I'm going to call the letter C count. Then after 500 milliseconds, I'm going to call the 6-letter count. So I have chained these one after another. 500 milliseconds for full count, 500 for C count, 500 for 6-letter count, then 500 for printing out the console. This is what I want to plan on doing. So let's go back to our code and see how that works. So on the code itself, I have the first setTimeout here, which does the get full count. Now remember I said that after the get full count occurs, then I need to have the get C count. So once we're operating the get full count, I set another timeout to get the C count. So 500 milliseconds after full count runs, get C count will run. Then I'm going to set another setTimeout and get the 6-letter count. So now after 1500 milliseconds, everything's occurred. And finally, after the 500 milliseconds after the get 6-letter count operates, then I'm going to do a console.log. So we got a grand total of 2 entire seconds that we're waiting for the data to print. Now, this first section here is called Callback Hell. And that's the official term for it too. I mean, you can look it up on the internet. Callback Hell is the old way that you had to work with asynchronous operations within JavaScript. Within all of these operations here, you always had a callback, and then you had to do something else within that callback, and that other callback may have an asynchronous operation too. So you would then have to wait until the asynchronous operation completed before you would do the next step, and then you would have to wait again till the asynchronous operation finished until you do the next step, and then again, and so on and so forth and so on. Within a good application, you could end up with 10, 11, 15 different callback functions, all of them listed exactly like this. It gets extremely difficult to be able to read that kind of information. I mean, the code works. I mean, we can flip back over here to Node, take a quick look at it, and yeah, the code works great. But from a maintenance point of view, it's very difficult to be able to figure out exactly what's going on with all of this because of all the different callbacks and all of the different functions that happen within the callbacks. And it gets even worse that if you have to execute 2 or 3 asynchronous operations at the same time, then within those 2 or 3, they may have to do other functions. That is why it's called Callback Hell. And the await function and promises were developed to be able to fix that. So let's go take a look at promises next. So what is a promise? Well, a promise is a JavaScript object that has 3 different states. The first state is a pending state. And this pending state is very important. It basically says that I am associated with some function or some code that will execute in the future, that when that code finishes executing, it will turn my state into one of the other 2 states. And what are those other 2 states? Well, those other 2 states are, first of all, the resolved state. And the resolved state says that whatever code was supposed to execute sometime in the future has now executed. And everything was good, and here is the data from it. The other state is the rejected state. And that says that whatever code was supposed to have occurred in the future has now occurred, but something went wrong, and here is the error code from that message. So again, those are the 3 states. Pending, I've got some code out there, has not finished executing yet, so I don't know what my final state will be. Resolved, I know what my final state will be, and everything is good. Or rejected, I know what my final state is, something went wrong, here is the error message. So let's see how all that is put together. So before we execute this program, we need to set up our functions as now returning promises and not actual data. So let's run back real quick to our callback program and take a look at our functions. Let's take a look at get full count since they're all going to be working the exact same way here. Before, I just set the value of full count and return params. Nothing simple, I mean nothing extraordinary, just real simple straight out of the box there. But now it's got to return a promise. So this is now the new full count function, and the first thing it does is it returns an actual new promise, and that's it. The promise itself takes a callback function. That callback function has 2 arguments, a resolve function and a reject function. Now again, remember, a promise has 3 different states, pending, resolved, and rejected. When you first create a promise, it always has a pending state. Now it can immediately go to resolve or reject, but normally some code is executed at some time in the future that then resolves or rejects it. So once this gets executed, get full count, it will immediately return back to JavaScript saying, I've got a promise here, but my status is pending, which means the code I have been told to execute is not executed yet. The callback function I have here now is going to be the set timeout, which means after 500 milliseconds, I'm going to execute the code. This is the critically important part you need to understand, is that I just hadn't simply returned from this function. I've already returned from this function. There's nothing to return to. I have to resolve or reject the promise. Now in my case, I'm resolving all the promises. Now remember, a resolution or resolve a promise says that my code is executed, everything is okay, and here is the value I want to give back to you. So as an argument to the resolve function, I am passing my params back. If I was to reject this for some reason, if some error had occurred, I would then pass an argument to the reject code that says, hey, an error has occurred, here is the error, and I'm rejecting the promise. So again, the idea here is that get full count first gets executed, it immediately returns a promise that has a pending status. Then after 500 milliseconds, it's going to set my full count property on params, and it's going to resolve that promise to params. But then JavaScript can take it and do whatever it needs to do at that point. And let's see how that works. So remember, our ultimate goal was to execute get full count, get C count, and get 6-letter count in sequence before we printed it out. How do we do that now that we've constructed all of our functions with promises? Well, this is how it's done. And the important thing is to understand two very critical methods, the then method and the catch method. The then method will get executed if the previous promise resolves. When the previous promise resolves, it will then execute the function that you pass in as an argument and pass to that function the value of that resolve. For example, get full count, as you know, comes back as a resolved params. So when it gets resolved, I pass my params variable back as the value of that resolve. Then we'll see that it says, oh, the previous promise was resolved, so therefore I want to execute get count. And when I execute get count, I'm going to pass as the argument to get count the value of the resolve. So in this case, I know for a fact that get C count will get passed the params value from the resolve from full count. Now, get C count also resolves params. So I now know that get 6-letter count will execute once get C count resolves, and it will get passed the value of the resolve, in this case params. And then finally, I've got a kind of little inline function here that says that I'm going to get past params from the get 6-letter count, and I'm just going to console log it. So again, the then method will not execute until the previous promise has been resolved. So get full count will be executed. It returns a pending promise. So I should immediately get the assigned all promises because I know none of the thens and none of the catches will execute because the promise is pending. Once it gets resolved, get C count will get executed because that's the first then. Well, get C count returns a pending promise, so I know that this then will not get executed, nor this then, nor this catch will get executed because C count has not been resolved. Once C count gets resolved, then I know 6-letter count will get executed. Its initial value is pending, so therefore I know this will not get executed, nor the catch, until get 6-letter count is resolved. And then finally, this will get executed. What happens if there's a rejection within any of that? It will just skip automatically to the catch statement here, and the catch statement will say, whoops, everything is bad. Well, I don't have a rejectance here, so I know that's not going to happen. So as you can tell here, I've now got it where we execute full count first, then get C count, then get 6-letter count, then do the console log. This is much easier to look at, it's much easier to understand, and is much easier to maintain than the callback hell that occurs right here. So how does this all work? Well, let's take a quick look at it within Node and see what happens. Node promise. Sign all promises, which I expected to operate to console log the first time because get full count was pending. And then I've got everything as I expected, just like the last time. I got my full count, my C count, and my 6-letter count. So promises are a fantastic way of organizing, and that's the best word to put it, organizing all of your different asynchronous operations within JavaScript. It is easy to look at, it is easy to understand, and it is easier to maintain than the callback hell that we had before. So the real key here is, what about await? Now we're going to finally get to await, and we'll show you how to do await next. And now we're finally to the await statement. Now, what again does the await statement do? Well, the await statement is just another way to visualize promises within your JavaScript code that makes it easier to understand and easier to maintain. It does exactly what it says. It waits upon a promise to resolve or reject. So let's take a quick look at what's going on here. First of all, before anything else, let me just show you here that all of my particular functions have not changed. They are all still doing a return new promise and a set timeout within the middle here. What has changed is how I am executing the awaits. Now, first thing I need you to understand here is that await can only be used within a function that has been declared to be an async function. Now, what does that do? It turns a normal function into a promise automatically. So when I call do async promise, I don't get just a normal return from it. I get a promise returned automatically. And in this case, a pending promise, just like before, pending, resolve, reject, it returns a pending promise. So it turns a normal function into a promise function. Now notice there's no resolve or reject here. And that's because an async function, when you return from it, automatically resolves it. And if you throw an error within it, it automatically rejects it. Or if one of the promises that are contained within the async function rejects, it will automatically reject it. So let's see how all of that works and how it works with the await. Now earlier I said again, await waits, kind of hard to say there, await waits for a promise to resolve or reject. So let's take a look at the very first statement here. Await get full count params. So this looks exactly like the get full count params that I got here in the original promise here. But on the await here, instead of just immediately going in and say, I've got a pending promise, continue on execution with all the JavaScript, it's now going to sit there and wait for get full count to either get a resolve or a reject within the particular promise. Once it hits a resolve, it will pass the value of that resolve to the variable that I've assigned on this statement here. And as you can tell, this looks exactly like a normal JavaScript statement. Let params equals get full count params is basically what I've said here. But by putting the await at the very beginning, I'm acknowledging that get full count is a promise function, and that I'm also acknowledging that I will not do anything else until it resolves or rejects. So while in a normal function, it would just immediately go to the next statement in the JavaScript because it's a pending promise and not a resolve or reject, instead it's going to wait until it is resolved or rejected. Once it gets resolved, it will go to the very next one. And once that gets resolved, it will go to the very next one. And once that gets resolved, it will go to the very next one until a return statement is hit, in which case the function, the async function, will automatically get resolved. What if one of these rejects? Well, if one of those rejects, it will automatically also reject the async function. So that's why at the very top here I have do async function and then a catch for that do async function, because I want to be able to catch in case any kind of errors occur. And of course no errors are going to occur because I haven't put a reject in any one of my options. So therefore, let's just recap here real quick. I first have an await within the async function because you can't have await outside of an async function. Each await function allows me to call the promise there, and it will wait until a resolve or reject occurs on that particular promise and assign the value of the resolve to the variable, and then so on and so forth. And for instance, I could have just as easily said let params1 equals await get count params, and now params1 would be the value of the resolve. In that case, though, I would also have to say await put params1 down there for get ccount, or else things would not have worked correctly. Now I'm not going to do that here, but I just kind of wanted to show you that that's one of the nice things about the await function is that it looks a lot like a regular JavaScript statement in which you take the value of the resolve that comes from the function and assign it to a variable. Let's just take a look and see how all that runs. Node await. And after about a second and a half, as you can see there, the assign do sync function automatically executed because, again, that was a pending promise. And then I got my data there. So the await statement is an absolutely wonderful statement to be able to even further organize your promises to make them look more like the JavaScript statements that you are used to seeing, and to work with it as if it was just a normal synchronous function. And that's kind of the key here, is that it basically, and I emphasize the word basically, turns an asynchronous operation into a synchronous operation. Did I get that right? Asynchronous operation to a synchronous operation. Await is a wonderful thing for you to be able to use and to add to your toolbox. So I highly recommend you take a look at await and study a little bit more about the things that it can do. So how about a real-world application? Well, I've got one for you. I have on my file system a listing of all of my animals in a JSON file. And each one of these animals has its own JSON file that gives me details on the animal. I want to be able to, first of all, read this file, and if the particular animal that I want to look up is located in this file, I want to get the detailed information for it. For example, here's the one for our coyote, and of course, obviously I brought this one up because that's going to be the one on the example. Let's take a look at Node first, and let's see how that operates. This is my end result. Here's the listing of all the animals, and here is the listing for the data on the coyote. So what does the code look like for that? Well, this is it. That's all there is to it. I have a function called lookupAnimals, and this function is get passed as an argument the animal I want to look up, and it has a catch that will catch any kind of error. So obviously we already know that lookupAnimals has to be some sort of promise, and that's where our await statement is located. So let's take a look. Here is the function. First, again, very important, I can't use await unless it's an async function. So I've declared my lookupAnimals to be an async function. Here are my particular awaits. I am awaiting to read the file that is specified right here. And this is my animals.json file. Now I'm using Node here, so I'm using their read file system. Now read file is an asynchronous operation. And with some of the newer versions of Node, you can actually have it return a promise instead of a callback. The older versions, it returned a callback. The newer versions return a promise. So I'm using the promise version here. So now I know that if I do fs.readFile, it will return a promise. So let's go back down to our code here. And our code will read in the file. And if it resolves correctly, it will parse it out, print it out. And then I do the quick test to make sure that my array includes the animal. And if it does, I get the JSON file, and again I do another read file that allows me to return a promise, and once that promise resolves, I then print it out and print out the animal. And that's it. That's all there is to it. There's really nothing else to it. And as you can tell, it works like a champ. So the secret here is that by using the await, I am able for it to wait until the Node read file method finishes up reading the file, whether it resolves or rejects. So what happens if there is an error? Well, if there is an error, then I have a little catch function up here that just prints out a little error message. So let's force an error to occur here. I'm going to go to animals here, and I'm going to change the file name to a file name I know it doesn't exist. I save it. Let's flip over to Node, and let's see what happens. Oops. Boom! Shakalaka. There we are. It gave an error saying no such file or directory. So why exactly did that happen? Well, remember, with an async function, the async function will always return a resolve on a normal return. But if any of the await methods or await statements inside there reject, it will automatically return a reject. And because it does a reject, it will run the catch statement at the very beginning here. So as you can tell, using the await is a wonderful tool to be able to use if you are having real-world applications, especially if you're reading from file systems like I did from Node here. And that's all there is on the await statement. I know it was a whole lot here because we really had to cover callbacks, we had to cover promises before we could even get to the await statement. So I really hope you enjoyed this video. I hope it didn't bore you to death. Please make sure to look up all our videos on www.boringjavascript.com, subscribe to our YouTube channel, or take a look at our blog site at thevirtuoid.wordpress.com. Thanks again for watching, and we'll see you later.